Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at the physical layer characteristics. We'll be discussing the physical layer standards, physical layer components, encoding, signaling, bandwidth, latency, throughput, and then finally we're going to look at Goodput. This episode is part of my series on Introduction to Networks. I'm Kevin here at KevTechify. Let's get this adventure started. When we talk about the physical layer standards, once again, we're at the bottom of the OSI model, but there's several different organizations that come into play when we look at this. We have ISO and IEA. IEA and TIA, they do some wiring standards, especially when we deal with the telecommunications side of this. ITU, ANSI, IEEE, these all make the standards of which the physical layer operates at. They generate specs for the voltage and the pulses, and we actually look at the physical wire size and what type of copper it is, and the protection and the crosstalk. And they engineer these specifications so they work for us, and we thank them for that. All we have to do is just use them. Once again, we are at the bottom of the OSI layer here. Now, the physical components. The physical components are the hardware devices and media that transmit signals that represent the bits. They transmit the signal. And so we have to go through a couple things when we do talk about the physical component. Now, when I mention physical components, typically what we talk about here is an Ethernet cable and a NIC. Network interface card that you can plug a wire into. Those are typically the physical components that a lot of people talk of. But there's a lot more on our network. Especially in bigger networks, we have routers and switches. That's what we're going to spend a lot of time in this course on, is looking at these routers and switches here. But at home, you probably have one that you at least see quite a bit, and this is that $50 Linksys Belkin D-Link router that you have your internet service provider connect to, and then all your other devices, whether wirelessly or wired, they connect into that. And these are all the physical components of a network. And there's more, but these are the main ones that we're going to look at and talk about. Now, we have to talk about encoding. Encoding is a process in which we can take our message. And once again, remember, we went through the layers of the OSI model, from layer 4 with the TCP segments down to layer 3 with the IP packets, down to layer 2 with the frames. We got this piece of ones and zeros we can now put on there. How do we encode these ones and zeros? Well, here's a method of encoding it over time. Whether the signal is high or low, that will represent is it a 1 or a 0. And that's what we're looking at here for this. Now, depending upon your media, there's different types of signaling that needs to occur. If we look here, the top one here is voltage over time. Well, voltage deals with wires. Wires here, that's what we're talking about, is our copper wires, our straight throughs, our crossovers, even our serial connections, our T1 connections. This is what the signaling would look like if you would pull out an oscilloscope and hook it up and look at it on one of those screens. The center one here, notice we have light pulses. If we're dealing with light pulses, that means we're going to work with fiber optics. And that's how the signaling works, is we send pulses of light through that fiber. And then the bottom one, well, it's voltage with the digital signal over time. That's a little confusing, but then notice the second one in that bottom one. It's voltage with AM. What do you think of when I say AM? AM, we think about the car radio, AM, FM, right? So we're dealing with radio waves. So now we're looking at wireless connecting up and getting our signaling across. We do need to talk a little bit about bandwidth and how much we're looking at. Here's a little breakdown. We have bits per second, kilobits per second, megabits, gigabits, and terabits. How many of those are? And basically what we're looking at is a multiplication of times 3. At 1 bit per second, one single piece of information is a bit. A kilobit is 1,000 ones or zeros. 1,000 pieces of information. Megabits is 1,000,000. Now all of a sudden we have 1,000,000 bits. And when we're talking bandwidth, we're looking at bits per second. First one is just 1 bit per second. You only can send one piece of information. Next one you can send 1,000, then 1,000,000, then 1,000,000,000. And it gets faster and faster over that. And so we have to have the technology to encode it and decode it, but we're getting faster and faster. And as we talk about bandwidth, we have to talk about a couple other terms. One term is latency. How quick is your network responding? Those of us who are gamers, we know that a high latency or a high ping in your game means you're going to react slower. You have a slower communication time to the server than somebody else. And they can sneak up and end your round really quickly before you even know what happened. So you want to have low latency that gets information through. Latency, in other words, is the amount of time, including the delays, for data to travel from one point to another. You want the quick latency. You don't want something slow. You don't want a lot of traffic or interference on your network. Throughput's another one. Throughput is a measure of transfer of bits across the medium over a period of time. How much information am I getting across that piece of copper, that piece of fiber, over this wireless connection? That is, how fast is my connection? Well, I have a fast Ethernet connection. That's 100 megs per second. I can get up to 100 megs. Now, we all know we don't get the advertised speed, but this is actually how much bits can I push across that connection. You go to some place like speedtest.net and you run the test, and they will tell you what your throughput is for your internet service provider. How much information can I push through in a certain amount of time? And then the last term here we got to talk about is Goodput. Now, Goodput is the measure of usable data transferred over a given period of time. Now notice it's usable data. Sometimes data has to be retransmitted because it wasn't good when it was sent. Maybe it had some interference, maybe it was cut off, and we have to retransmit it. So that first part of the data that you sent, you can't use it. You have to get rid of it. So that doesn't count as Goodput. Maybe you're running some protocols on your network that takes some of your bandwidth away. Maybe you're configuring your devices through your in-band method. You're configuring a router or switch through in-band. You're taking away some of your bandwidth. You can't actually transfer the data across the network you need to get there. You can't get those Word documents. You can't get those streaming conference calls across your network because you have other stuff going on. Goodput is the amount of throughput, the amount of data you're putting through your network minus that traffic overhead. And if you have a lot of overhead, your Goodput is going to be a little. You want to get that traffic overhead as small as possible to get your Goodput as big as possible. The closer you can get your Goodput to throughput is, that's a great network for you to have. It was my pleasure to provide you with this wonderful episode on physical layer characteristics. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.